This is 3.2, and we're solving, but now we're going to undo addition and subtraction in order to do the solving part. Okay, so a reminder that our task is to solve the equations with each term by undoing operations to isolate the variable. So again, what does all that mean? One place that I always want you to start, especially if you're like, where do I even begin, is read equations out loud. Okay, I've had tons of examples today of students being like, Mr. Younger, I don't know where to get going. I'm like, okay, well, read it out loud to me. And they would say, hey, that is x minus 1 equals 5. And they go, oh yeah, to undo minusing 1, I just need to add 1. So I'm going to add 1 to both sides. Now, one thing that I think can help us is on our equation, let's draw a line down the equal sign. The reason why we're going to do that is that if we do something to one side of that line, we need to do something to the other side as well. The other thing I want us to add to this is after we decide what we're going to undo, we're going to draw a horizontal line. And what that is going to tell us is we now need to pause for a second and figure out what happens after we add 1 to both sides. Well, the whole purpose of this was to undo the subtracting of 1. So those cancel out. I like actually seeing the canceling because now I'm like, what's still on the left side? Well, it's just an x. And it equals 5 plus 1, which is 6. So as soon as I have the x by itself, I am done. And we'll circle our answer or box it. All right, so number 2. Anybody that asks me about this, I'd say read the equation out loud to me. The best way to say this is absolute value of x minus 1 equals negative 7. We need to undo the minusing of 1. So we're going to add 1 to both sides, like what we just did. Again, I like that line down the middle of the equal sign. That way, if I do something to one side of that, I have to do the same thing to the other. And the horizontal line tells me, hey, let's figure out what we do after we add 1 to both sides. Negative 1 plus 1 cancel out. So I have the absolute value of x equals negative 7 plus 1, which is negative 6. I get a lot of students that when they get here, they go, oh, hey, if the absolute value of x is equal to negative 6, that means x equals 6 and x equals negative 6, because Mr. Youngren said we should always get 2 answers with absolute values. But what happens if I take the absolute value of 6 and the absolute value of negative 6? What does that equal? When we take the absolute value of a number, what always happens to that number? It's always positive. So when I'm like, hey, if I want to take the absolute value of a number and get it to be a negative, is that possible? No, right? So these are not answers, okay? Those would be answers if we had absolute value of x equal to positive 6, but the negative 6 is not possible, so our conclusion here is that there's no solution. Okay. One thing that's going to show up in some of these problems for today is we're going to have double signs. What I mean by double signs is like a plus and then a minus, or a plus and a plus, or a minus and a minus. I would always recommend simplifying. If we have 2 signs, what is the one sign that kind of takes over? Okay, so simplifying the double signs and rewriting it. So our first example of this is number 3. If I were to read that, it says x squared plus negative 1 equals 15. Well, if I have plus a minus, that minus does not have another negative to group up with to create a positive. So basically, this is still just subtraction. So this is really x squared minus 1 equals 15. So if we have these double signs, we're going to always rewrite it with one single sign for whatever takes over. No, just because adding a negative, we're still subtracting, right? If I have 5 plus negative 1, that's 4, so we're still subtracting there. Okay, so it takes over because that's just how the addition of negative numbers work. Okay, that it still just equates to us subtracting. And so now, reading this out loud, it's a little more clear to what to do next. X squared minus 1 equals 15. Just like all the other equations, we're going to add 1 to both sides. And so x squared equals 16. We now need to undo the squaring because undoing the squaring is how we get to just the regular x. So I'm going to square root both sides. The square rooting and the squaring cancel out. And so I have x is equal to the square root of 16. So I'm thinking about what numbers times themselves as 16. How about positive 4 and negative 4? Positive 4 times positive 4 is positive 16. Negative 4 times negative 4 is 16. Okay. Number 4. Reading this out loud is 2 to the power of x minus 1 equals 31. I need to add 1 to both sides to start. That way we work to get the exponential term by itself. So I get 2 to the power of x equals 32. This is a harder exponential fact, and why I want us to do some work off to the side to figure out what that exponent needs to be. So what we're trying to figure out is 2 times itself how many times will get us to 32. Let's start with a fact that we should know at least a little bit easier, and that's that 2 squared is equal to 4. Well, we're going to have to multiply this by 2 a couple more times to get to 32. So let's figure out what is 2 cubed. Where does that get us to? That's 2 times 2 times 2, which is 8. So we're still a ways away. So let's try 2 to the power of 4. Well, that's just 8 times 2, which is 16. So not quite there, but 2 to the power of 5, which is 16 times 2 is 32. That's the fact that helps us. Okay, so for us to find our solution here, we need the exponent, which is x, to equal 5. Okay. Let's just rewrite 5 and 6. And I'm going to have you do 5 through 8 on your own, and then we'll do 9 through 12 together to finish this. So again, when we have the double signs, number 9 is a really good example to why I want us to rewrite them. When you have 2 negatives, okay, there's lots of ways of how we can explain this, but I like to just visualize. If I got 2 negatives, they come together and form a positive. Okay, so 9 minus negative x is 9 plus x equals negative 10. This has been confusing to a lot of students because they are like, how do we undo that 9? Is that 9 being added, subtracted? What's really going on there? We can rearrange this equation so that it is x plus 9 equals negative 10. And now it should be very clear to what we need to do with that 9. Okay, so this last step that I did, it's not necessary. I'm just doing that so that way we have a better idea to how we deal with that 9. And really it's being added, even in how I wrote it the first time. I'm going to let you all kind of take it from there. Okay, but before I let you work for a few minutes, number 6, I have 9 plus a negative absolute value of x. The negative does not have anything to group up with, so it stays as 9 minus the absolute value of x, and it equals 20. Again, we can rearrange these terms. Okay, so that's a little bit more clear to what we need to do next. The absolute value of x, it is negative. So I'm going to rewrite it as negative absolute value of x. And the 9 is positive, so plus 9 equals 20. All right. I want you all to do your best to work through 5 through 8. Okay, and then we'll do 9 through 12 together to finish class here. Okay. Let's check our work here. Okay, we're going to actually run out of time, so we'll just save 9 through 12 for next time. So eyes and ears up here. Okay, number 9. We already did the work of combining the 2 negatives to say that we're adding. So the first thing that we want to do is subtract the 9. And again, I did not need to rearrange the equation. The only reason that I did that is so that it becomes very clear to how we undo that 9. As soon as I see it of the 9 plus x, I can minus 9 right there. And you get x is equal to negative 19. Okay, then for number 6, again, I did the rearranging, so I have negative absolute value of x plus 9. So same idea, we subtract 9 to start. So the negative absolute value of x equals 11. Then we don't like that negative absolute value of x. We need it to be a positive. So I have to divide both sides by -1. So the absolute value of x is equal to -11. Absolute values can't equal a negative number. So our answer is that there isn't one. It is no solution. Number 7. That 9 we can get rid of by subtracting. So -9 from both sides, and I get -x squared equals 4. Dividing both sides by -1, I get x squared equals -4. When you try to square root a negative number, the calculator will yell at you. It says you can't do that. It says domain error. That's because no number times itself is ever a negative. So our best way to state that solution is that x is a non-real number. If you say no solution, that's fine with me. Okay, I would not count it wrong. Right, then number 8, -9 plus 3 to the power of x. So I add 9 to start. 3 to the power of x equals 1. The fact that helps me is that 3 to the power of 0 is 1. So that tells us that x has to be 0.